Okay, welcome back guys. We're going to be solving another question from chapter 2 of Meriam textbook, question 4 to 5, and we need to determine the moments of detention T about point P and about point O. So there are multiple ways to solve this question. Let's start with the moment about point O. So if we want to go with the point O, we can dissolve the T in these two directions. And if we do that, basically the component that passes through the O won't make any moment, and we only have the moment of the vertical component. We know this angle is 90 degrees, and basically we will have that moment. So let's call this moment MO, and we're going to consider counterclockwise positive. So if we go with that, we know this angle would be basically 90 minus alpha minus theta, because we have a right angle. So force that we have is T. So if you look at the moment, we'll see that the moment is first of all clockwise moment, so we have a negative sign, and that angle is T times cosine of 90 minus alpha minus theta, and the distance that we have in here is R. So we know that also this part is cosine of 90 minus alpha plus theta, and we know this is equal to sine of alpha plus theta, and from here we can find a moment of minus T times sine of alpha plus theta times R, which would be the final answer for this one. So that's one way to solve this. But let's just solve it with two different methods. That was the first one for going with moment about point O. This is probably the fastest way to go for finding the moment. But if we want to go with doing the X and Y component for T, so this will be our X component, which will be T cosine of alpha, since we know this angle is alpha, and this will be T sine of alpha. And if we want to find the moment about point P, let's call it MP, counterclockwise positive. We can see that both of them are actually in clockwise direction, both X and Y components, so we have negative sign. And what we have in here also, the negative sign shows that the moment was clockwise. So if we want to go with this, we have a negative sign. Let's go with the X component. So this will be our Y and X. So we have T cosine of alpha times the vertical distance that we have, which is basically this distance from what we have in here, which is R plus, if we look at this right triangle here, this side is R sine of theta, so R sine of theta, and we have the moment of the Y component, which was minus T sine of alpha, negative sign again for clockwise moment, and the distance that we have is basically the other side of this triangle, which is what we have in here, or R cosine of theta. So this will be R cosine of theta, and what we're going to get in here is that minus T, we can factor one R in here, so it will be R1 plus sine of theta. So we get minus TR, and if we multiply cosine, we'll have cosine of alpha plus cosine of alpha sine of theta, and from the second one we can do the same thing, minus TR. This time we have sine of alpha times cosine of theta, and now we can factor minus TR in these two, so basically we have cosine of alpha plus cosine of alpha sine of theta plus sine of alpha cosine of theta. So if we look at this part, this is a familiar expression for us, and that would be the sign addition in trigonometry, which is the formula that I have in here. So what we're going to get at the end for the moment about P will be minus TR times cosine of alpha plus sine of alpha plus theta. And again, we have a negative sign that shows the moment is clockwise, and that's going to be the final answer for this question. By the way, we can use the same thing going with X and Y component for finding the moment about point O, which we're going to get pretty much the same thing, but like I would say this would be the faster way, because we can cancel out one of the components of the T since it passes through the O, but we're gonna get the same answer at the end of the day, and it will be your preference. So yeah, that would be all for this one. Please let me know if you have any questions, any comments. Feel free to drop it in the comment section, and don't forget to subscribe, like, and comment. It's gonna help me to reach out to more students, and I'll see you guys in the next video. Have a good one.